In this episode of the podcast, I talked to Tachi, who is the CEO and a co-founder of Playgrounds Analytics. Playgrounds began as a blockchain data company that developed some tools in Python to allow people to access and analyze blockchain data more easily. As large language models exploded onto the scene, Playgrounds experimented with developing LLM-powered chatbots for blockchain companies, but eventually realized that that business model wasn't going to scale as much as they wanted. So most recently, Playgrounds began developing a software development kit for developers to produce large language model powered applications in blockchain and beyond. So in this conversation, Tachi and I discuss the development of Playground's business strategy over time, the Rust programming language, blockchain, as well as the mechanics, risks, and proper use of large language models. If that sounds interesting to you, you're welcome to join us. Okay, so to start though, really, what is Playgrounds? How did it start and where is it going?
Good question. So as of right now, Playgrounds is an AI tooling company. So we build a Rust library or an SDK that allows engineers and devs or anyone interested in
An
building.
SDK is software development kit, right?
Yes, that's correct.
Okay.
We build a library or an SDK that allows anyone to build AI applications or LLM-powered applications using a library. So we call it RIG, and it's primarily focused on building applications using Rust. Rust is a programming language.
Relatively new, right?
Relatively new. As it's performant, it's faster, it's more efficient. It has a lot of characteristics that makes it a preferred programming language or system to build more efficient, large-scale or small-scale applications as compared to Python, for example, which most libraries or SDKs are built with. So for example, like LangChain or Llama Index, these are LLM application frameworks that allows you to build applications in Python. Ours,
For LLM specifically.
for LLM specifically, ours is using Rust, for example. So we're targeting, we like to call them like the intense engineers who really care about memory efficiency, who really care about optimization, who really care about performance and speed, concurrencies, and all of the other advanced features that comes up with when you're building anything with Rust. So right now,
concurrencies, this is a basic question, sorry. Is concurrency the same as parallel processing?
No.
Or is that different?
It's different. So parallel processing, you have multiple operations or multiple systems at the same time. Concurrency it can be confused, but in this case, you essentially have systems that do operate asynchronously with each other, and systems that do rely on the outputs of another are kind of clustered together, and then the output feeds another, but that other operation does not have to wait for the output of another operation. So it almost looks like parallelism, but it's more async. It's like an async process versus parallelism, which is everything is happening at the same time. So another good example is, let's say you have a program that has 4 functions in it. A concurrent system would mean that 2 out of those programs can basically just start and do what they need to do without having to wait for the other 2 functions to complete their job. So they're happening concurrently. And so with the Rust library, we're able to build, AI applications that if you do need some kind of concurrency, or even if you want to do parallelism, you can do it with Rust. You can easily do it with our library.
And you would want to do that for the sake of performance?
Performance, yes. And sometimes you might have really complicated applications, or your system is getting bigger and bigger. You want to have the flexibility to leverage a highly efficient language that allows you to build without worrying about memory leakage, or allows you to prioritize memory optimization. And so Rust is this really cool, it's an advanced language. It's fairly new, but it's gaining a lot of popularity because of how efficient it is to work with and to use.
Would it be true to say that Rust is a lower level programming language than Python?
In a way, yeah, in a way.
How does it compare to C?
There's a lot of similarities.
Okay.
A lot of similarities between the both of them. And so one thing about Rust as well is, you could know Python, or let's say you have an application that you've built in Python and you want to optimize some aspect of it in Rust. We have Python bindings that allows you to interface a Python program with a Rust program. And I don't want to get too deep into Rust because this conversation is about AI. But our focus is building this SDK so that Rust developers have the freedom to build what they want to efficiently. So that's where we are right now. But as far as origins go, we started out as a blockchain data company. We used to build tools that allows you to not only index, but query index blockchain data. So the issue with blockchains and blockchain data specifically, it's so encoded. It's so, there's a lot of activities that are not necessarily legible. So you can see events and transactions or activities on any given blockchain, but it's extremely difficult to immediately understand or make sense of what you're looking at. Um, and so our goal when we created Playgrounds, by we I mean me and my co-founders, was to create intuitive tools that allows you to not only find the data that is meaningful to you, but to query it and then get that data in an environment that's much more familiar to you. Say, query blockchain data for some activity around some wallet or account, and then pull that data into something as intuitive as a CSV file, or even better, like an Excel spreadsheet, and then you can plot graphs and do pivot tables and what have you. So we did that for a while. It was really successful. The library is called Subgrounds. It's a Python library.
And so essentially what you're doing is you're providing a interface to blockchain data.
Exactly. Like a very intuitive interface to query and analyze or work with blockchain data. And so we did that for about 1.5 years, going to 2 years. And the reason we focus on blockchain is what the beauty of blockchain technology itself is, it's this immutable, I guess the simplest way to put it is it's this immutable database that is accessible globally. Anyone has access to this database. Activities are permanently imprinted on the network. And so you can't have a false actor try to falsify data. It's also transparent. It's easily accessible. It's democratized. It's decentralized. So everyone has access to this, whatever specific blockchain you're interested in, and you can build applications on top of the chain. And so fundamentally, like that has significant impact in the way we operate. Like what I mean by we, the world, is you have this shift where databases are no longer obfuscated or put behind some veil or centralized.
Because it's not necessary to maintain them in a centralized, it's not necessary for one central entity to maintain that data.
Yes. And also the risk of said centralized entity to maybe tamper with the data or own your data. It belongs to everyone. Everyone can access it. Everyone can read into it or write to it. And so there's this really cool shift that we perceive as happening, where most operations, most systems will probably have have some interface with a blockchain, just because it's just a new way of interacting with each other in an open, permissionless way. You can create an application on a blockchain. We call it a decentralized application or a DApp. And in just a few lines of code, you can deploy this thing, and I can interact with this. You can create a service without having to go through the normal process of getting permission to use some server somewhere. It's fully permissionless. Anyone can build on this system. It changes the way the world might work with each other.
When you say anyone can build on this system, it's still necessary for you to have your own servers to power that, right? Or no?
No, it is not.
So you're saying that's what you mean. It's not necessary for you to provide that computational power?
Essentially, nope. All the computational power is essentially distributed. There are nodes that essentially process all of the activities, transactions, or actions that are going on the blockchain, verifying them, making sure they're accurate, making sure that they're correct, making sure they're true. And that's a whole nother, conversation on what is a blockchain and how does it work. But in essence, really, all you need is just a laptop, a programming environment where you can write code that can execute on a blockchain. We call these smart contracts. And you deploy it, you push it into the network, and now everyone has access to this piece of code or this smart contract. And now that smart contract could be anything. It could be insurance, for example. Like, hey, I have this piece of code or this smart contract that says, given two parties, A and B, and some other parameter, and say, okay, if A and B are going to, we're going to call this smart contract the Tachi insurance policy. And the Tachi insurance policy is connected to some satellite data or some other type of event. And it's basically monitoring the data that's necessary. And then it says, if A and B or A, B, and C, however many people choose to participate in this smart contract, they put money into this. And the rules of the smart contract is, if a hurricane happens in some country that's relevant to A and B, automatically release funds to the affected party. That is a very simple insurance policy that you've created, where it is governed by code. The code and the data is what dictates when the insurance policy activates. Hurricane happened. How do I know? Well, the data shows that hurricane did happen. How sure are you? Well, a million nodes validated that this event actually did happen. So the code executes, and whoever is the recipient receives the funds. That's a very simple explanation of how you can create a very simple insurance policy or insurance smart contract and deploy that on the code. And anyone who sees that, reads the code or reads the functions, okay, cool, like, very simple. I put money into this thing, and the rules are, if X happens, Y happens, right? And so there's all kinds of applications that could be built using this technology.
And so you and your co-founders see this and you think, that's exciting. We're going to build a business on top of that.
Yeah, that's
Playgrounds
exciting.
Analytics comes into being.
Yeah, because we saw that, it's a $1 trillion ecosystem, but the problem is you need expertise. You generally need expertise. You need an engineer. You need to understand how to read and interact with not just the blockchain, but even to understand the data that's being generated on these chains. But how do you get mass adoption when only a select few with expertise and the patience can actually understand the data that's being generated?
So your mission was to democratize the interpretation of blockchain data.
The ability to read and understand what's going on the blockchain by providing tools that you're already familiar with.
And that's how you started.
That's how we started. We built a Python library because, number one, Python is one of the most popular languages for data analysts and data scientists. It's also extremely robust in that most analytics tools have some way to work with Python, where you write a simple script to move data from a source into the environment and you analyze it. So we built this tool that allows you to query index blockchain data and then push that into an environment like Tableau, Excel, or even a CSV file or Jupyter Notebook, and you can do the work you need to do. So the library is called Subgrounds. It's open source, free to use. Anyone can use this library. And so we did that for a while, and we always knew that there will be an intersection between AI and blockchain. It just made sense that you have this system, the blockchain, that essentially records. It's a record-keeping system, right? It records human activity. It records knowledge, right? And at least what AI is today in LLMs is the system that needs to be grounded in knowledge to do its work. Well, it makes the most sense that perhaps the best knowledge source to build AI application would have to come from blockchain data. Like, you would have to ground your AI applications or your AI agents on a knowledge source that can be trusted, that is verifiable. You can always look back at it and say, what is the data that this AI is using to do its work? Well, it's using data that's locked away or that's generated on the blockchain. Oh, okay, well, I trust it because I know that the data stored on the blockchain is immutable, it's verifiable, it's accessible. So we knew that there would be this intersection between blockchain and AI. And so, sometime around last year, we started making a pivot into building, experiments. Let's build an AI agent that can read blockchain data, where you can ask a question and it finds the answers, all the data, the relevant data on a given blockchain or a given knowledge source, and then provide an answer.
Which essentially is an improvement on the interface you were already providing in some
way. It really is, because if I were to break down the mission into components, right? Like, what is the story that a data analyst or just any regular person who's interested in working with data, just take away blockchain data, just say data. What is the story or the objective, and what are the paths that any data consumer normally has to take to go from a question they have to an answer using data? Well, they have to discover the source of the data, then they have to essentially query it, then process it. That's the process of analytics, and then tell the story. Right? There's four distinct work streams that anybody who wants to consume data generally has to go through. They have a question: what is the financial health of some business?
Mm-hmm.
They have to go through discovery. Where can I find the data that can tell me the financial health of this business? Okay, I found it, the discovery phase. Then they have to query it, query only the data that can answer my question. They get the raw data, then they process that. Okay, I need to do pivots, I need to do modeling and whatever on this data. Then they tell the story. Given this data, I can tell the financial health of the business is whatever, like they have X amount of dollar in the bank accounts. This is the users of this product and whatever, right? And so that was like the guiding framework. As we need to build a system that allows any data scientist or data analyst or data consumer to easily continue their work stream, even though the source of data now is with blockchain. So using our library, which we built on a network called the Graph, which is this orchestration system that indexes blockchain data. So essentially find the data they want. I'm looking for this particular data, query the data using Python, which is much more familiar, process the data using Python as well, and then tell a story, well, using Python as well, right? So
and so at this point, you have somewhat democratized querying blockchain data by making it accessible to Python developers who might not have special expertise in blockchain. And yet that Python programming skill is itself a form of expertise. And so if you can make this data accessible through an LLM, then maybe you can even further democratize access to this information.
You got it in 100%. It's, well, this was the question we asked ourselves. We knew at the time Python was the simplest expressive language, where like it was a language where you can just express what you need in the syntax and get the data you want, process it, and analyze it. You're speaking the language of Python to do this thing. With the advent of LLMs or GPTs, well, that changes. Now, the simplest language to discover, query, process, or analyze and tell a story using data is plain English. You just speak your intent and you basically get the data and the interpretation in plain English. And so that's when we really...
In
theory, right? And so that's when the light bulb hit that Python is great. It is the lingua franca for data scientists and data analysts in the world. But plain English is actually a lot more intuitive because we already speak this, right? And so we then, essentially dove headfirst into, all right, how do we build a natural language interface that allows you to query and interpret blockchain data using natural language? So we built an agent, a very simple AI agent, an LLM agent that speak your intent. How many users of this product, of this application on the blockchain, how many users are there in the last month? And it understands your intent, it understands the question you're asking, and then using the tools that we built for this agent, it finds the right tool that can query the data, get back the data, and then either feed you the data in its raw form or feed you the interpretation of the data after it's been queried. So that was the first experiment we built, was a very simple AI agent called a PGGPT. And the interface to talk to this thing was in Discord. Essentially, you just ask a question, finds the tools, queries the data, provides the response back in Discord, almost like you're having a conversation with another person in Discord, but it's actually AI. And so we did that. We did the experiment, and then we really got into it, started building a lot more tools. By tools, I mean the APIs and the systems that the AI needs to interface with the blockchain, find the data that's relevant, query the data, and then provide a response back to you.
Okay, you're equipping your agent.
Essentially, yes, giving it a toolkit. And it's a really fun,
and that makes your agent more capable, but it does not increase the complexity of the interface from the user's perspective. it just gives them a more capable tool?
It gives them a capable tool, but it gives them a more intuitive interface, because now they don't have to set up a Python environment. They don't have to set up this whole program like you write code. So you set up a VS Code or whatever. They're chatting with this thing. Like they're literally just expressing the question. However it is their mind is conjuring up the inquiry, and the agent is able to understand what you're really asking for, and then using the tool that can best answer or meet the user's need. So we simplify the way people can find answers to questions that they have related to whatever is going on the blockchain. And so building tools is really fascinating, because essentially any API or function that you already have, whether you wrote it in Python or whatever, essentially can be converted into a tool. You take a function. Let's say this function's job is to call an API. We call this function calling. Call an API, and the way you convert that into a tool for the AI is literally you take that API as is and the function as is, and you just describe what the function does. You describe it. Say this function's sole job is to take some arguments or some parameters, query some API, and the response is going to come out in a JSON format. This is an example of what the response will look like. Once you have that description, then there's like a very simple process of embedding that as the tool for the AI. And so when it's looking for the tool in its toolkit or its library, it says, okay, I'm looking for a tool that has an API to query this particular type of data. It looks through all of its tools and say, that tool, based on the description, is more than likely what I need. And it uses that tool. The output of that tool is fed back to the agent. The agent processes or synthesizes a response based on the response of the API, and the response is given back to the user.
Okay, and the way that that's working is your agent, this LLM, is creating a semantic score of the description that you're pairing with the tool.
Yeah.
And it's comparing that with a semantic score of the prompt from the user submitted in Discord.
Yeah.
And then calculating the probability that this tool is able to provide the data that the user is asking for, or it's calculating the probability that, what is it? That I guess I don't understand. It's because it's okay, go ahead.
Yeah, the technical term for that is it's called a semantic search, or embeddings, or vector embeddings. Essentially, what happens is the semantic representation of text is represented numerically as vectors. So you have imagine you have this space, this box. Let's just use for simplistic analogies. We just have this box that's meant to hold vectors, or semantic representations of things. It's multidimensional because things can have multiple meanings. And so there's primarily two inputs to this thing.
So it's a vector. Sorry, it's a vector because words can have different senses?
Essentially, yeah. And it's have different directions. And so when the user asks a question, the question is tokenized. It's converted into what we call embeddings, which just vectors.
And tokenized meaning some like a parser or a lexer or
so if you have a sentence, it's like cut up into little chunks. Or let's say, I am a boy, right? Like I am a boy. Like those have like numeric representations, or the vector representations of those. Then
are tokens always words?
Tokens could be characters. They could be in grammar, right? Like a period would be a token, for example, or a comma could also be a token. But a word could also be a number. Could be a token.
And what you're looking for is a semantic unit.
Yes.
Like a meaningful unit.
Yeah. And so
so you're tokenizing the prompt, meaning you're breaking the prompt into units which are distinctly meaningful.
Yes.
And then you're quantifying that based on the training of the algorithm?
Yes, exactly. Yeah, you got it. And so you have the input of the user's prompt. And then generally you would have another source, which is where the text or the training or the knowledge comes in, which it itself is tokenized, right?
But this is prior to your use of the LLM, right?
Yeah, so that's.
Or are you talking about something else?
There's two aspects to this. So GPT itself means generalized pre-trained transformer models, right? And so there's this pre-training thing where the foundational model itself has been trained on a vast amount of text, right? So it has like this pre-training. It has like this out the box understanding of the world, because
Would it be right to say that you are, I don't know if I'm making this analogy correctly. I'm thinking about like tuning parameters in a machine learning model.
yeah, you think that
Like
that's basically tuning.
you're looking for the values
Mhm.
that allow this model to make the least wrong predictions.
Yes. Yeah, you're essentially course correcting it till the the predictions it's making, like the next word prediction is making, is more than likely the correct prediction to
Mhm.
it, right?
And is it, I think I saw something recently that said these LLMs or GPTs can have something like 1.5 billion parameters in a model. Is that true?
Yeah, there are all kinds of models. There are some that have much smaller um, parameters, but it really, in the world of LLMs, they have all kinds of models that are specialized for some type of task. Some
Hmm.
are much more
Like
generalized.
codex.
Yeah, exactly. It's so it really depends on who's building it, why they were building it, what the application of that model would be best suited for. Like ChatGPT, for example, is one of the, it's a large model. It has trained on basically the collective knowledge of mankind, all the data on the internet. It's all part of its pre-trained data that it has.
And so we must, I mean, this is way beyond my understanding, but you don't have human engineers designing 1.5 billion parameters. We're allowing the model to form its own parameters
Yeah, it's basically
and
just
then tune them
yeah, we're feeding it. We the humans fine tune, right? So you
with
interact.
feedback.
Yes, you interact with this model. The output is not quite what you're looking for, so you give it you fine tune it by adjusting the weights and parameters till the output is close to, or it's not, you can't really say exactly what you're looking for because these systems are not deterministic. So it's around the sphere of what you're looking for, so you keep fine tuning it, but then you can use GPTs out the box and get something meaningful. But when you want to start building applications that are specific to your use case, there's a more than likely chance that the out the box model, like the GPT, like GPT 3.5 or whatever, does not have knowledge of the data that's actually meaningful to you. Let's say, for example, your business.
Hmm.
There's a high chance, almost a certainty, that it has no idea what your business is or what data is useful or what data your business generates. And so this is where you augment
Okay.
the model's understanding of your data so you can build your application on top of it. So this is kind of where, like, we call it RAGing, or it's retrieval augmented generation, which is given a out the box model, GPT 3.5,
Hmm.
want to augment its data that it has with your own data, right? Okay, so you have the GPT in this box here. Then you have the user's question that's been tokenized, converted into vectors, whatever.
Hmm.
Then you want to, alongside, feed it your own data, which is also tokenized, converted to
Hmm.
vector, and then the
And
similarity
broken into chunks, right?
broken into chunks, broken into different chunks of semantic meanings, right? And
But is it,
mhm,
I know this is changing
mhm,
quickly
mhm,
now, but isn't it true that one of these models can only look at a limited amount of it can only incorporate a limited amount of context in
mhm,
an answer to a particular prompt? And
mhm.
so you break this augmented you break this augmented data into chunks that are smaller than the context limit?
Yeah, so what you're describing is a context window, right? So there's only so much information that I would say attention that an LLM model can have. And so right now, I mean, there's a lot of updates like GPT 3.5, 4, 4.0. They have like these large context windows, which means that you can feed it large amounts of data,
Hmm.
and you can still you can have a long conversation within the context, right? But
And
earlier
mhm.
models were much more smaller, so you had to essentially optimize your system where the chunk of text that it's paying attention to answer your question or to respond to your prompt is the right size that's fit into the context window, so you can have a conversation within that context, right?
And then when you submit a prompt, the algorithm would be doing a semantic search over these chunks of
Exactly.
context and then choosing the one that's most likely related to the prompt, and
Yeah.
then out of the tokens contained in that context window, generating a response.
The response. Exactly.
But as the capability of these models expands to analyze a larger context window in a single conversation, that part of the process becomes less relevant.
Yes, exactly.
Okay.
So the world of LLMs and what you can do is pretty large, right? There's things like prompt engineering. Like, okay, what does that even mean? That's how do you construct your prompt so that your intent, what you're really trying to get out of it, is expressed in a way that the LLM understands what you're trying to get, or even just constructing the knowledge source you're feeding into it in a way that's easy for it to quickly understand the semantics, the various semantics,
such as the description of the tools that you are. Did you say you're embedding it? Is that the term that you use?
Yeah, you're
and when you say that, you're talking about like the vectorization of the tokens.
Exactly. That's exactly right. Yeah.
And you consider that to be prompt engineering also, because you are equipping your LLM from the developer side to respond to user prompts.
Yeah, exactly.
Okay. So that's two different senses of that term.
Yeah. So I guess to kind of ground it, I want to make sure, like, because for the sake of people who are listening, when what we're talking about here, like, what does context mean, right? So the simplistic description of context window in the topic of LLMs is the amount of text that the model can see at any given time. It's essentially like the window through which the model reads and understands your input text, which is a combination of your prompt and your knowledge, like your data that you're feeding to it, right? So you can adjust the size, and based on the context, it affects its understanding. It affects the way it responds, because let's say the answer to your question wasn't necessarily within the context window, then more than likely the response that you would get will be incorrect, because it couldn't see the data within that context window that you set
it's like you and I have been talking on this recording for 35 minutes. And so if I made a high level reference to something that we've said before, like if I mentioned something about playgrounds, anybody watching this recording would understand what that means.
Yes.
But if I start talking about the potter that Emily and I went to make that vessel for my wedding, all of a sudden that reference is outside the context window.
That's exactly right. Yes.
The context window with which a viewer of this recording would be interpreting what we're saying.
Yeah. Yes. Now, if you use a newer model, like the newest one from OpenAI, GPT-4, then you can say, well, the context is so large that we can be having these conversations about LLM, but you can just throw a random question. Oh yeah, I kind of also want to quickly go back to this pottery thing that we talked about an hour ago, and it's still within the context because the window is so large, right? So that's kind of very top level. So anyway,
go ahead.
Going back to playgrounds and how all this fits in, we started building agents that you can feed in a prompt or a question, and feed in custom data or knowledge, and ask questions about the data that you fed it. Right. And so that's how we started serving customers and users. People could use our agents to ask a question. So we had all kinds of agents for all kinds of things. We had an agent for our business itself, right? So we fed it custom knowledge or custom data about playgrounds, our docs, our website, our GitHub repo, our FAQs, how to use our libraries, and it basically became like a customer service assistant because it had all of that knowledge as part of its grounding.
So you built that for playgrounds, you built it for other people. Has anything changed about your business model since then?
Yes. So we originally, we thought, okay, maybe
because you weren't working in Rust when you began that experiment, right?
It was Python, yeah. And so we did some market research. We built a product. We call it the AI interns. And the idea of the AI intern is for any business, like the idea of an intern, right? It's like this bright-eyed kid or whatever, or someone who's really wants to work for your business, and they know everything there is to know. They don't sleep. They're always ready and eager to answer questions and provide information about the business that they're interning in, or provide value. So the idea of the AI intern, it's this agent that's awake 24 hours a day, 365 days a year, and it is grounded in all of the knowledge there is about your business, your websites, your docs, your forums, the past conversations that customers have had with each other or with the team. And it just exists in the environment where the business operates or where the business interfaces with your customers, which for the industry that we work with, most of the customers talk to businesses in Discord, Telegram, Slack, emails. So you imagine that customer can just show up in the business's Discord, like, hey, I tried to use this service, I got this error, what's going on? And the AI intern provides the answer to help that customer. But we quickly realized that perhaps chatbots, which is really what they are, AI chatbots, is not necessarily the most scalable thing to build. There's already just so many chatbots out there basically doing the same thing. Is it meaningful to double down on building chatbots? And do the responses that the agents or the intern provide, are they at a place where the responses are 100% accurate? No,
Right.
because LLMs hallucinate. All
They
of
do
this,
weird stuff. They overfit.
yeah, exactly. They're always hallucinating. All responses are hallucinated. The whole point of grounding in knowledge and optimizing it is just to guide the hallucination so that what it's hallucinating is correct, or sort of, right? So we realized that no one really knows what the right product that intersects AI and blockchain really is. It might not be chatbots, but what we do know is that the tools to build whatever that ultimate product is must be built.
Okay.
And there's not a lot of good tools currently
Okay.
to do that.
Interesting.
Hence the pivot is, why are we building cars when we can just build a factory for anyone to build whatever car they want to build? And that's where we are today. Is our library or SDK is essentially this generalized factory with all the tools you need, all the components, all the models, right? Your vector store, your database, connectors to popular knowledge bases like Google Drive, SQL databases, emails, whatever components you need is available in our library. And then we make it easy for you to start building the Lego blocks. I want to build an agent that connects to my Google Drive so I can ask questions about documents in my Google Drive. Well, use the library. Here's an example on how to do so. Or I want to build an agent that summarizes tweets. Well, use our library. Connect it to the Twitter API, instantiate an agent. Boom, you have an agent, right?
Okay, so the saying goes, when there's a gold rush, sell shovels.
Yeah, basically.
So the gold rush would be people wanting to create LLM-powered applications.
Yeah.
You're selling the shovel, which is this SDK, this software development kit that gives people the toolbox to build those things. And you decided to make that pivot because you found yourself creating these chatbots and thought this might not be the right application. And we actually don't know exactly what the right application is of LLMs in AI.
Exactly.
And maybe nobody does. And so, or I mean, maybe somebody does, but we'll see. Come out eventually, and maybe they will have built their thing on Playgrounds. And so you said, we're going to support experimentation. We're going to support builders and create tools that we know are going to be generally useful no matter what particular application anybody's making or anybody is developing. And so you're creating, would it be right to say you are building a layer of abstraction on top of Rust for the purpose of facilitating the development of LLM applications in the blockchain domain?
Yeah, yes. And we're actually, because now we're, building this factory, this SDK, we no longer necessarily have to focus on just blockchain, on the blockchain industry. Because
interesting.
In theory, what we've built is a knowledge orchestration system where the knowledge can come from whether it's blockchain or your own private database or your business's knowledge store, right? Just
your data plumbers.
Yeah, essentially. Yeah. Come with your data.
No. You're the data plumber hardware store.
Exactly. Yeah. Come with your data, like you have your data wherever it's stored, and bring it in its true form.
Wow, that almost fits your name better.
Yeah, play around with. Yeah, yeah, exactly. Yeah, it's we want to make it as playful. We want to make the process as simple, almost like building Legos, right? That you have all the
Wait,
Legos.
have you ever, is it too late for you to change your name? Because you could totally go by Toys R Us.
I think that's a copyright infringement at risk there.
What if you just spell R correctly?
Toys R Us. That's funny. Home Depot for data.
Okay, well, so
Mm.
I think I understand. This is cool. This is good because now I'm up to date on playgrounds. Is that basically the whole situation? Because I have some questions for you.
Yeah, that's basically it. That's what we're doing today, and that's how we started.
Okay, so you know more about LLMs than I do, but I've got some problems with these things. Well,
Okay.
really, I've got one major problem, and I made a video about this a few weeks ago. This was the one I was telling you about. LLMs produce an output that resembles the output of a professional human craftsman. Maybe that craftsman is a writer who understands how to organize knowledge in a way that's sensible and easy to understand. Maybe that craftsman is an illustrator. Maybe that craftsman is an animator or a team of animators. When OpenAI Sora produces a animation of a woman walking through Japan in response to a prompt, it looks professionally good, except for the fact that as she's walking, her left leg is moving forward, and then all of a sudden it switches with her right leg. In the past, when human beings have encountered an output that resembles professional craft, it's because it is professionally crafted. And there's no way that professional craftsmen would allow the kinds of errors that we see slip through the output into the output of these LLMs, such as the woman's legs moving back and forth, or the bizarre errors that we see in illustrations, and also the bizarre errors that we find in text outputs. Or I haven't messed around with Copilot very much, but I've heard that the same thing happens. Well, actually, that's not true. I have seen this happen when I've asked for code from Gemini, that it will give me things that don't, it will suggest that I use things that don't exist. Because in general, the output of these models resembles professional craft, I think that we are vulnerable to failing to critically evaluate that output as we should, because we have learned to associate from experience general intelligence with the semblance of professional craft. Like if a craftsman's able to produce an illustration that is that good, he knows there are 5 fingers on a hand. Because people's reading comprehension is not that great, I think that we're at greater risk of allowing these bizarre errors, these hallucinations, these overfitting errors to slip into text and into code, because we're just not looking very carefully. Like it's pretty easy for us to spot 7 fingers on a hand, maybe less easy for us to spot a equally as egregious logical error in a paragraph.
Okay.
And so because these types of errors do occur and probably will forever, I mean, to some degree, well, although that's something that we could talk about, it seems to me like we need to know how to write and we need to know how to code, because we need to at least be able to supervise these things. And we need to learn to analyze their output with discipline rather than trusting them inappropriately.
Yes, that's true. So, I mean, these systems are still so new.
Yeah.
And you are right. We're not at a place where we can essentially just offload the work to AI system or an LLM system and just say, okay, yeah, well, we trust that the output will always be good because it's just intelligent, whatever.
Although you know people are doing that. Like there are like online marketers who are saying, write me an article about XYZ, and then they're copying that and they're pasting it and they're putting it on a website and not telling people that it's generated by AI.
Yeah, some people would always find shortcuts and do that. But I think that where we are right now is still at the very, very early stages of things. And we've seen these models get increasingly better. Feedback is provided. Humans are still needed in the loop, right? To criticize, to correct, course correct, or whatever. And so yeah, like we're not anywhere close to fully autonomous, hands-off, no human need. I don't even think we would get to a point anytime soon where humans can be fully hands-off. So I guess I'm trying to infer what your question is are we there yet? No.
I guess, well, okay, so my most practical question is, given the state of these things, how exactly do I use this? Where is the boundary between appropriate and inappropriate use? So we can say blindly trusting the output of an LLM falls soundly into the category of inappropriate use. But I think also refusing to use them entirely is unreasonable. Where's the line? Like, how do we use these things wisely today?
That question, take away LLM and AI, applies to how do you use a tool? How do you use a hammer? Are you using the hammer to hammer a nail into a wall, or are you not using it to chop up steaks? And what
Yeah,
it's
agreed. It's just this tool is new, and so we have to ask the question
yeah.
all over again.
Yeah, and I think the best is not the best. My answer to that is I see it as just a tool. It's just another. It's LLMs are great semantic computing systems, right? Like prior to the advent of GPT, the transformers, or whatever, like the way we, yeah, I'm speaking primarily in just software, right? Is things were done schematically, schematics, and you have like a schematic for a problem that you want to solve, and your schematic for the solution. You write the code, you can criticize the code, and you kind of design things within those constraints defined by schematic.
And this schematic would be like an abstract machine.
Yeah, it's like you just have like the architecture, right? Like say, I need to write code that does X, Y, and Z. Then you write the syntax or the functions to do that thing.
Yeah, okay.
With LLMs, you're able to write functions or programs using semantics only, right? And so the way I see LLMs today is it's a new type of tool that allows me to perform operations semantically. So am I letting it just fully write the code or write a paragraph or whatever? No, it's just another tool. The same way autocorrect was a tool that allows you to write the thing that you want to write and then just suggest that a correction could be made. That's what that tool was used for.
You know, it's funny that you compare it to that. Maybe this is partly my personality. I don't let Word correct my spelling mistakes. I like that it highlights my mistakes, but I go back and I retype it myself because I want to know how that word is spelled.
Oh yeah, well that's a good way. I definitely use spell check when I'm writing documents. I'm like, is this right? Was there a comma that was supposed to be there? And like maybe I learned from it, but I definitely use. But the main point is, as of right now, the best way to approach the systems is to see them as just another helper, another tool to do your work faster and more efficiently. And yeah, the line is kind of being cautious with over offloading the cognitive work that you need to do onto the machine, right? And so it really is just a tool right now. It's a tool that allows you to not only work in the schematic realms of things, but also finally we have a tool that allows us to work with semantics as well, right? So I guess for listeners, I suppose, like what exactly do I even mean by semantics or semantic computing, right? Like LLMs basically allow for semantic computing. Semantic computing basically focuses on deriving meaning from text or intent from text and processing the relationship between words, sentences, concept using natural language, where schematic computing
based on probability.
For semantic based probability.
Based on an enormous amount of what we call training, which is a statistical analysis of text.
Yeah. So semantic, you can really go in and say, okay, well, if you really want to dive in, right, going back to semantic computing, right, it's these tools or this techniques allows you to work with meaning ontologies, knowledge graphs that represent and infer meaning, right? So it really like opens up more of like this tool. It really just opens up more of what you can imagine and what you can do, because now as an engineer or a writer or whatever, you finally have a tool that allows you to quickly switch between just staying in the semantic sphere. Like just I'm in pure idea mode right now, and I'm just gonna pour my thoughts and my intentions, what I'm really trying to do. And this tool is going to essentially assist in chunking up things semantically, and it's still your responsibility to now look at this output and go, okay, cool. Like I can work with it. I can do these.
Okay, so you're saying this allows a new kind of work. Do you use Copilot? Is that your primary?
I use Copilot to code check, to write documentation, especially because I can be very lazy. I write my whatever program I'm working on, whatever project, and I generally would have to write documentation that explains what the code does. And of course, I just like highlight it in Copilot, and I ask Copilot, like, hey, can you just quickly write a documentation for this code I wrote? And of course, I still have to read it to make sure that the documentation it produced is of high quality. I enjoy.
Or if not, fix it.
If not, I fix it. Or another really cool thing that I use Copilot for, or even just ChatGPT, is, I say, hey, I really want this thing I'm writing to resonate with someone in like high school, because I'm a very technical person. So I tend to almost always, like, by not even intentionally anymore, over explain things or go a little bit too technical into things. And I can provide what I've explained in my way and say, hey, can you just like show me how I can re-explain this in a way that's easily consumable to a high schooler or someone in elementary school. And the tool, again, using it as a tool, not as the worker for me, will make the suggestions. Well, if you were to remove this section, or just use this analogy, or use any analogy, which here are some examples, you can re-explain what you just wrote for an elementary school student or a high school student. And I can take that and say, okay, cool. Let me rewrite what I wrote using the suggestion that's been provided. That allows me to do my work more efficiently. I'm not just copy pasting its output, and I don't suggest anyone should do that. And just like, yep, copy paste, like you said, some bloggers and whatever would do that. It really should just be seen as a tool that allows you to do your work a little bit more efficiently, just like a spell check does, right? Some of the other tools that humanity has built over since the beginning of civilization to make life a little easier, so we can do more work. But I really wanted to really clarify what I'm really trying to say when I say LLMs are semantic computing systems as opposed to what we had prior. And so, like, what do I mean by schematic and semantic? Like the schematic computing system is when you have like a predefined structure or schemas that organizes and interprets data in the context of language, right? If you like Python or whatever, and you have like the syntax or syntactic patterns.
Which is more like a machine. We call it a language, but it's a machine, and that machine has triggers, and those triggers are labeled. They're labeled with words that are meaningful to the user, but it's highly structured.
Yeah, it's formal. It's like
formally structured.
Yeah,
okay.
Schematic computing basically uses formal grammars, syntactic trees. It's a lot of rules and structure of language to perform certain tasks, versus LLMs allows you to basically do that, but semantically instead.
Well, because it hides all of the rules from the user. Its rules are actually far more complex if it has 1.5 billion parameters.
Yeah, it's just
but it develops those rules through this process that we call training, which is a statistical analysis of an enormous body of text. And that produces a statistical model of language which is good enough to produce human-like responses with only a small number of terribly absurd errors.
Yeah. There's an article I'll send to you after this, and I really like the way the writer, who I really respect, described it. It's LLMs are universal translators for intent. And so they, by means of semantics, they translate an intent from one form to another, or text from one form to another. So you can have like a raw idea that's poorly structured, but that could be converted into a mathematical equation that has the same semantic representation of the input. So I could have a poem I wrote, and I could say, give me, I don't know, like a linear equation that represents what I just said, right? Or you could take an image and you could say, write me a poem that represents the meaning of this image. It's a general translator for semantics.
And that works because,
yeah, that's it. That's basically.
Semantics means having to do with meaning. What is meaning? Meaning is, it's at least implication for action, and maybe more than that. Like if I'm driving down the road and I pass a dentist's office, and that dentist's office has 14 bushes in front of it, that's not a meaningful fact. Why? Because nothing that I do will change if I know that or not. It has no implication for action. But if I'm driving down the road and there's a roadblock because there's construction along my usual path, and it has a sign that says detour pointing this way, that is meaningful information. Because I know that, I now will take a different action in order to achieve my goal.
Yeah.
So that meaning is at least that. And maybe there's more because, but I don't know. I mean, I'm thinking like if you see a meaningful piece of art, or if you hear a meaningful piece of music, maybe somebody could argue that has no bearing on your action, but I don't know about that. I think that when something is meaningfully beautiful, it does affect us in a way that affects our action, because it speaks, well, maybe to get back to our earlier conversation, Aquinas says beauty is integrity, harmony, and radiance.
Mhm.
Integrity, it's whole. Its parts are in harmony. They reinforce each other. They all aim at the same thing, like they're united into whole under one aim. And it's radiant, meaning it shines forth meaning, like it speaks. So even fine art, I think, is like that. And what it speaks to us does affect our action when we interpret it as we should. So anyways, meaning, I think we can say implication for action. I think that's a decent definition. So when I have something to say to you, there's something meaningful. Like I have meaning inside of me that I'm trying to convey.
Mhm.
But that meaning is pre-verbal.
Mhm.
I have my meaning before I convert it into words.
Mhm.
And then my words are signs of my meaning
Mhm.
that indicate my meaning, and then you are decoding those signs so that you can make contact to the thing that I meant before I said it.
Mhm. Your intent.
Yes, because words derive from meaning, and because meaning is connected, there is a statistical relationship between the words. So what I mean when I say meaning is connected is, as long as I'm speaking the truth about reality, my meaning is one because the truth is one. Like if I make an error, now all of a sudden that error is not one with everything else. Like it's separated. It's a poor representation of reality, but reality is one. And so the truth about reality is one. And so if I mean to say something about reality, then that meaning is a part of the one truth. And so then my words, which signify that meaning, are a part of the set of potential representations of the one truth.
Mhm.
So you could say that that set of representations is one, just like the truth is one, just like reality is one. Does that make sense?
Yeah, that makes sense. Yeah.
And so because that set of representations is one, I can analyze it statistically and identify relationships that allow me to probabilistically anticipate the next word that's going to come in a sentence.
Yeah, you've
And
described exactly from a very beautiful way how LLMs work.
but then here's something that I think is important to understand. That is always a heuristic. It can never be anything more than a heuristic. And that's different than your speech and my speech, because you and I can regard reality, and reality speaks to us, and we can have understanding that is not merely heuristic. And then we can represent that as faithfully as we can manage, sometimes with great precision. That is not mere probability. And I think if we can understand that, if we can remember that, then maybe we can use these models appropriately and draw the line in the right place.
That's a good point. Yeah. Yeah, this shift that's happening in the way man interact with machine, interact with man. What LLMs or AI is essentially giving birth to, or like what emerges, is there's going to be this change in the way we kind of express ourselves, and how do we express meaning and our intentions. I think that this is where, like I was trying to say earlier, the next, big, perhaps it's a prediction, like the next big hot job will be writing again. Formal writers, they'll be like as hot as software developers were in the .com boom, right? Because we're going to need people who can understand the heuristics, who can understand how to speak, who can understand how to take the pre-verbal, package it in a way that the machine understands exactly what we're trying to say, so that the predictions or the next words that it's spitting out aligns with our intention.
Mm-hmm.
Yeah.
Mm-hmm. Faithful articulation in English is the new development, because all development is, I should say, it's not dead yet, it's still here. Development's like, hey guys. All that is articulating intent, articulating will in a form that is compatible with the machine that executes that command. Okay. All right, man. Well, we've gone over time. You've spent a lot of time with me today. I would love to talk to you more about this. Yeah, this has been really great, man. And send me the recording for this so I can listen and find where I could improve and explaining certain things. Yep. I'll send you both. Thank you. Have a wonderful day, Zach. You too, man.